Hello, this is Mr. Dowling. I'm going to give you a quick little lesson on what are variables and units. If you already know what a variable and unit is, or you feel you already know it, please still listen to this video as I will expect notes to be taken, and it's a lot easier to get to a notebook and look up when you forget what these are than it is to get to YouTube, especially when in class. As you know, that's very difficult to do and usually will get you banned from your computer use. So, just take a few notes so that you know what we're doing. I'm going to move on. Now, a variable, variables you've seen before. You've done variables before. I mean, let's go back to math, like way back in math, like before junior high. You will get questions like this of 4 plus 2 equals, and you'd be like, what is it? I don't know. Well, I got to remember. Or I have to use my fingers. So you're like 4 fingers, and then I put 2 more fingers up, and I get 6 fingers. Awesome. So I get 4 plus 2 equals 6, and I have solved my problem, and I go, yeah, I'm awesome. So we've been able to do that, and that's great. But then you went to algebra, and they went, hey, you know what? We're gonna throw a curveball at you. Instead of leaving this part blank, what I'm gonna do? I'm gonna erase this. Oh my goodness! There's missing information. How in the world are we supposed to solve this? How could I possibly know what is here? There's a blank spot. We need to put something in the blank spot. I'm gonna throw a curveball at you. I'm gonna put a letter in there. Oh my goodness! There's an X. It's a letter. What does the letter mean? Well, a variable, that's what that X is. It can mean anything. It could be any number in the entire existence of all numbers. It could be 11 quadrillion billion. I don't know. Except we put some limiters on it. We look around us. Oh, we have a 4 over here. 4 plus this mystery number has got to equal 6. And so, oh, how do I solve this? Oh, basic algebra. I remember how to do this. It's rearranged the problem to solve. I subtract the 4 over because it's being added to the x. I subtract it over here, and what do I get? I get 2. Oh my goodness, I get 2. I box my answer like a good student, and I say, I'm awesome, because you are. So what is that? That tells us that x must equal 2. That's a great thing to say because we've now solved for x, and we've proven that a variable must equal a number. It will always equal a number. There is no time in which it doesn't equal a number unless it equals another variable, which then equals a number. And by the transitive rule of algebra, it equals a number. So variables equal numbers. It's very important to know. But that was Algebra 1 knowledge. That was simple stuff. Now I'm going to bring you to Algebra 2 information on variables, because you might remember this. When you got into Algebra 2, we started doing things like graphs. I know you're going, boo, graphs. How dare we have to write little cross lines with tick marks across it to denote distance and have to do equations that deal with lines and intersecting of lines and the chaos behind it. Well, I'm going to show you the very simple equation you probably saw many times, the slope-intercept form line, which is y equals mx plus b. And you looked at this the first time and said, alphabet soup. Yay, alphabet soup. Probably not the yay. What is this? Look at, there's not a single number in here. It is all letters. In fact, you could probably try and say it as a sentence. It's really hard to say. It's a sentence. It's not math. How is that math? There's no numbers. Each one of these variables equals a number. And depending upon where you are in this graph, these numbers change. This is much more like physics that we're going to be dealing with. I'm going to bring your attention to mostly just 2 of these variables at first. First, I'm going to bring you the variable of x. Now, x was the x-intercept. It's very simple. You put in x, you go, well, I'm going to put in x of 1. Why? Because I counted 1 over. Well, if I put in x of 5, then I count over 1, 2, 3, 4, 5, and there's x equals 5. This is just like the Algebra 1 math. This is x equals 5. Very simple. It is a variable equals to a number. But I want to draw your attention to this variable, the m. Now this one, there's no x and y coordinate with an m on it. The m equaled slope. This wasn't just a straight number. It was a number that really meant something. It wasn't just like I count over 5 and put a dot. I mean, x means something, but you just associate it as a dot on a graph. M meant slope, which changed the way your graph looked dramatically. Let's say m was equal to 2. That meant that I had to make a slope of 2. Rise over run, rise over 1. 2, 1, 2, 1. that means that my slope, my graph would look something like this. It'd be a much steeper slope if all the other numbers were equal. That tells me that not only does this 2 mean, this m equals a 2, which is a number, it means that this 2 has an inherent quality of it. Now, I could talk to you about lots of other variables and lots of other equations. And I'm going to talk to you one maybe you understand a little better if that didn't work for you. Let's go about height. Let's say, how tall am I? Now, I said tall and height. They're interchangeable in English. So my height is 6. 6. Well, I'm going to put a stick figure up here of me. Now, on this graph, my stick figure here is 1, 2, 3, 4, 5, no, not quite there. There we go, 6. So I'm 6y tall, but we don't like to say 6y tall. In the United States, we use feet, so I'm 6 foot tall. My height is 6. That's very important to know. My variable, what it is I'm measuring, height, is 6. My variable is equal to a number. That is a very clean definition that I want you guys to write down. I'll have it at the end for you to copy. So a variable is equal to a number. It is what we are measuring. Okay? Now, units, as I said in the last one, my height was 6. I said feet, so I'm going to put feet right here and put it in red so you see it. But here's the thing. My height doesn't necessarily always equal 6 feet. I could write this differently, couldn't I? What if I didn't want feet? What if I wanted to know how tall I was in inches? Well, if you guys remember, inches, there's 12 of them in a foot. 12 times 6, 72 inches. Now I have two different numbers, but they are equal to each other. They are both equal to h and therefore the same number. How does that happen? It's because the units are different. See, variables tell me what I'm measuring. Units tell me what I'm measuring with. Both of these appear on a ruler. I can just pull out a measuring stick or a tape measure and I can measure my height. And I could say, hey, look, it says 6 feet, also says 72 inches. If I knew the conversion, I could do it in millimeters, I could do it in meters, I could do it in miles, I could do it in light years, I could do it in any type of measurement for a distance, which is my height from how far away I am from the floor when standing. That's what height is. I can use it. It's still equal to my height. I am still measuring my height. I am using feet or I am using inches. That's what a unit is. A unit tells me what I'm using. Now, an important thing to know about units is they always have a number in front of them. They have to. Otherwise, they don't have any meaning. If I just walked up to you and said, I am height feet, it would make no sense. Because you don't know how many feet. You are a foot or are you many feet? You need to put that modifier in the front, the number in front, to let us understand. Now, in physics, there's going to be quite a few problems that will come up in word problems. So I want to talk to you a little bit about an example for a word problem using height. So let's just say, I'm going to say Bob because I can write that easily. Bob is, let's say, 7 feet tall. Now, if you were to read this in a problem, and it was like a long problem, it says Bob is 7 feet tall. He is moving at the speed of blah, 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 and let's just focus on the one sentence. Bob is 7 feet tall. In this is information. If you remember, feet is a unit. So I'm going to underline that in red so you can see it. Feet is a unit. Now, if Bob is 7 feet tall, and I know feet is a unit, so I'm going to write feet and 7, what is that unit equal to? Well, it's a measurement of distance, but I got this special modifier right here that says tall. Now, I'm not just measuring, say, how wide he is or how long he is from a place. I'm measuring his tallness or his height. This is important information. I have just now listed Bob's height is equal to 7 feet. This is a part of your list that you're going to need to do later, so make sure you understand how I did this. I read through the problem. I found the unit. I check for modifiers to tell me what variable it was associated to. I know feet is a measurement of distance. I know that if it's measuring how tall he is, we are measuring the height distance. Height is equal to 7 feet. This is important to know how to do. This is one of my steps for solving problems with a 5-step process that I'll be going over in another video. So in the end, variables are equal to a number. H, the variable, is equal to 6 feet. Units have a number in front of them. H is equal to 6, and the feet is the unit. When you get to much later ones, we're going to have to memorize units to variables. I will tell you this, they are very simple to memorize what a variable stands for. It's pretty easy because almost every variable, except for a few of them, start with the letter they're measuring. H measures height. D measures distance. Speed is measured by the unit variable is, the variable for speed is s. The variable for velocity is v. You can see how these things kind of work out. So make sure you'll have to spend time memorizing which unit to variable are which, but it's very important that you understand them because you'll need to know how to identify them in a problem.